Heat dissipation in Snapdragon processors, an overview. This document provides an overview of the factors influencing heat dissipation in Snapdragon processors. It highlights the typical power dissipation range of these processors, the key factors affecting heat generation, the relationship between power consumption and heat production, and the phenomenon of thermal throttling. Understanding heat dissipation in Snapdragon processors. Snapdragon processors, like all processors, generate heat as a byproduct of their operation. Understanding the factors that influence this heat generation and dissipation is crucial for optimizing device performance and longevity. It's important to note that there isn't a single, universal figure for the heat output of Snapdragon processors. The amount of heat generated varies depending on several factors, including the specific processor model, the intensity of the workload, and the device's cooling system. Typical power dissipation range. Modern flagship mobile processors, including Snapdragon chips, typically dissipate power between 5 and 16 watts. This power, almost entirely, is converted into heat. This range provides a general idea of the thermal load that these processors can generate under typical operating conditions. However, it's crucial to remember that this is just a range, and the actual power dissipation can vary significantly based on the factors discussed below. Key factors influencing heat generation. Several key factors influence the amount of heat generated by a Snapdragon processor. Processor model. Different Snapdragon processor models have different architectures, manufacturing processes, and power efficiencies. Newer models are often designed to be more power efficient, resulting in lower heat generation for similar workloads. Older or less efficient models may generate more heat even under moderate use. Workload intensity. The intensity of the workload being processed by the Snapdragon chip has a direct impact on heat generation. Demanding tasks, such as playing graphically intensive games, running complex simulations, or encoding video, require the processor to work harder and consume more power, leading to increased heat production. Conversely, light tasks like browsing the web or reading emails require less processing power and generate less heat. For example, gaming creates significantly more heat than browsing the internet. Device's physical cooling design. The physical design of the device plays a crucial role in dissipating the heat generated by the Snapdragon processor. Factors such as the presence of heat pipes, vapor chambers, thermal paste, and the overall airflow within the device all contribute to the effectiveness of the cooling system. Devices with more sophisticated cooling systems can dissipate heat more efficiently, allowing the processor to maintain higher performance levels for longer periods. Devices with poor cooling designs may experience more rapid temperature increases and be more susceptible to thermal throttling. Power consumption and heat production. A fundamental principle to understand is that nearly all the power consumed by a processor is converted into heat. This allows for a straightforward calculation. The power draw in watts directly represents the rate of heat production in joules per second. For example, if a Snapdragon processor is consuming 10 watts of power, it is generating heat at a rate of 10 joules per second. This direct relationship highlights the importance of power efficiency in minimizing heat generation. Thermal throttling. High temperatures can be detrimental to the long-term health and performance of a processor. To prevent damage, Snapdragon processors employ a mechanism called thermal throttling. When the processor reaches a certain temperature threshold, it intentionally slows down its clock speed and reduces its power consumption. This reduction in performance helps to lower the temperature and prevent overheating. While thermal throttling protects the processor from damage, it can also result in a noticeable decrease in performance, especially during demanding tasks. This is why effective cooling solutions are so important. They allow the processor to operate at higher performance levels without triggering thermal throttling. In summary, heat dissipation in Snapdragon processors is a complex phenomenon influenced by various factors. Understanding these factors is essential for optimizing device performance, preventing thermal throttling, and ensuring the long-term reliability of the processor.